Welcome. Now that you have learned about the basic components of a VPC, you can start routing traffic in interesting ways. In this section, you will learn about VPC networking options. An internet gateway is a scalable, redundant, and highly available VPC component that allows communication between instances in your VPC and the public internet. An internet gateway serves two purposes. Number one, to provide a target in your VPC route tables for internet traffic. And number two, to perform network address translation for instances that were assigned public IPv4 addresses. To make a subnet public, you attach an internet gateway to your VPC and add a route entry to the route table associated with the subnet. A network address translation, or NAT gateway, enables instances in a private subnet to connect to the internet or other AWS services, but it prevents the public internet from initiating a connection with those instances. To create a NAT gateway, you must specify the public subnet in which the NAT gateway should live. You must also specify an elastic IP address to associate with the NAT gateway when you create it. After you create a NAT gateway, you must update the route table that is associated with one or more of your private subnets to point internet-bound traffic to the NAT gateway. This will allow instances in your private subnets to communicate with the internet. You can also use a NAT instance in a public subnet in your VPC instead of a NAT gateway. However, AWS recommends that you use a NAT gateway instead of a NAT instance because a NAT gateway is a managed service that provides better availability, higher bandwidth, and less administrative effort. VPC sharing enables customers to share subnets with other AWS accounts in the same organization. VPC sharing enables multiple AWS accounts to create their application resources, such as Amazon EC2 instances, Amazon Relational Database Services, Amazon Redshift clusters, and AWS Lambda functions into a shared centrally managed VPC. In this model, the account that owns the VPC shares one or more subnets with other accounts called the participants that belong to the same organization. After a subnet is shared, participants can view, create, modify, and delete their application resources in the subnets that are shared with them. A VPC peering connection enables you to privately route traffic between two VPCs. Instances in either VPC can communicate with each other as if they were on the same network. You can create a VPC peering connection between your own VPCs with a VPC in another AWS account or with a VPC in a different AWS region. When you set up the VPC peering connection, you create rules in your route table to allow the VPCs to communicate with each other through the peering resource. For example, suppose that you have two VPCs. In the route table for VPC A, you set the definition to be the IP address of VPC B and the target to be the peering resource ID. In the route table for VPC B, you set the destination to be the IP address of VPC A and the target to be the peering resource ID. VPC peering has some restrictions. First, the IP address ranges cannot overlap. Second, you can only have one peering resource between the same two VPCs. Third, transit peering is not supported. This means the traffic from a VPC goes to the second VPC and it stops there. It cannot go to a third VPC. By default, instances that you launch into an Amazon VPC cannot communicate with your own remote network. You can enable access to your remote network from your VPC by attaching a virtual private gateway to the VPC, creating a custom route table, updating your security group rules, creating an AWS site-to-site VPN connection, and configuring routing to pass through traffic to the connection. One of the challenges of network communication is network performance. Performance can be negatively affected if your data center is located far away from your AWS region. For such situations, AWS offers AWS Direct Connect. AWS Direct Connect enables you to establish a dedicated private connection between your network and one of the Direct Connect locations. This private connection can increase bandwidth, throughput, and provide a more consistent network experience than internet-based connections or VPN connections. Direct Connect uses Open Standard 802.1q virtual local area networks. On occasion, you will need to connect VPC resources to AWS regional services like Amazon S3 and DynamoDB. A VPC endpoint is a virtual device that enables you to privately connect your VPC to these supported AWS services. A VPC gateway endpoint is a gateway that you specify as a target for a route in your route table for traffic destined to either Amazon S3 or Amazon DynamoDB. Traffic between your VPC and these services does not leave the Amazon network, so it remains private. More recently, AWS has introduced AWS Private Link. It requires a VPC interface endpoint. AWS Private Link simplifies the security of data shared with cloud-based applications by eliminating the exposure of data to the public internet. AWS Private Link provides private connectivity between VPCs, AWS services, and on-premises applications. All traffic flows securely on the Amazon network. AWS Private Link makes it easy to connect services across different accounts and VPCs to significantly simplify network architecture. We have mentioned the idea of VPC peering to connect to VPCs. Consider how will you connect hundreds of VPCs together. Each VPC pair will require a dedicated VPC peering connection. The complexity of connectivity can become a heavy burden. A transit gateway is a network transit hub that you use to interconnect your virtual private clouds. You can also connect on-premises network. You can attach a VPC, AWS Direct Connect gateways, or VPN connections to a transit gateway. The topology becomes a hub and spoke, which reduces the number of connections required, the complexity to implement, and be able to maintain it. Thanks for watching. We'll see you in the next video.